Okay, we begin with the recording. So remember, if you cannot see this live, you can go to I'm going to give the link to the YouTube channel, and then you can watch the video later. So, okay, let's just go back to this thing. So to share the screen right here with you, the unit circle. So you remember that you complete this in class. It's boring, but it's not difficult. This is going to give us the values of the trigonometric functions or trigonometric ratios when the angle is more than 90 degrees. Remember that you have to memorize the first quadrant, and you have the famous left-hand rule to remember the sine of 0, sine of pi over 6, pi over 4, and so on. Then with the values of the sine, you can generate cosine because are the same but reverse it. Then you get tangent because it's the quotient of both. Cotangent, the reciprocal of the tangent. Secant, the reciprocal of the cosine. And cosecant, the reciprocal of the sine. And then you continue getting the values for angles more than 90, just reflecting this, just reflecting the values you have for the first quadrant. So this is the point. Once we have all this table, we can go to, for instance, in Desmos. I have something here in Desmos. Let me just go back here. Share screen Desmos. What is Desmos? Oops. Let me see if I can check this one. Right here. This one. Okay. So we have this one. Share screen. This one. Okay, you can see here Desmos, right? Now, let me just now go back to this part and then look for, oops. Where are the functions I save? Okay, secant function, sine function, right here. Okay. So remember, these are the points you have from the table in the unit circle. If we continue doing this for angles more than 90 and more than 360, 720, and for negative angles, what we are going to see is this graph that pretty much you are familiar with, correct? So this is the graph we see for the sine function. You can get this one in the Desmos or in the calculator, whatever, right? Okay. So the same may happen, is going to happen, but different functions. For instance, I have here the cosine. If you see here the cosine, we can see here the points from the unit circle. And when we continue with the same values, we see that the function repeats and repeats and repeats. We're going to have the same for the tangent function, open the tangent. You see here the points from the unit circle. And if we continue with this, we can see the tangent function. So the idea is this one. Trigonometric functions are periodic functions. They repeat. So we're going to see graphs like these ones for all of them. Now, where are they? Okay, let me just stop share right here. And let me just go back to the assignment we are going to be doing today, this one, right? So share screen right here. So here are the graphs of all the trigonometric functions we have to work, right? Here is the tangent, the cotangent, the cosine, the secant, the sine, and the cosecant. So pretty much you're familiar with these functions, so I'm not going to be working too much them. The only point I'm going to try to do is, well, we have to work with the inverses of these functions, okay? Wow, the inverses. Okay, let's go back to algebra 2. Yeah. Inverse function. Possibly you remember what is the inverse function, but the inverse function, if you have a function f of x, f to the negative 1 is an inverse. If you perform the composition, you get the x. So f negative 1, f of x equals x. So this is the point. The inverse is a function that if you make the composition with the original, you get a single x. That is very simple to verify. Let's do something. F of x equals x squared. That's a very simple function. Remember your algebra 2. Find inverse function. Everybody remembers what you did. You changed the x by y and the y by x, correct? And then you solve for y. That is the procedure, remember? So in this case, y equals x squared. Then you do the change, x equals y squared. Then you solve for y. Y squared, you square root x. And remember that you have two values, y equals positive, negative square root of x, right? Then what you have to do is choose one. Usually you get the positive x. That was the procedure, correct? And if we want to verify that they are inverses, this is well, the only we have to do is the composition. If we take f of the square root of x is the same as the square root of x squared, and the square and the square root cancel, this is x. Then we take f negative 1 of x squared, then the square root of x squared, they cancel out, you get the x. So this is the way the inverse work, correct? So there is not a very big problem with this one. I'm assuming you remember this from algebra 2. So we can do another example, for instance, the cube. For instance, you have f of x equals x cubed minus 1, correct? Okay, let's take y equals x cubed minus 1. Then we change the y by x and the x by y. X equals y cubed minus 1. Then you solve for y. Y cubed equals x plus 1. And then you cubic root. This is the cubic root of x plus 1. We can verify this is the inverse. So this is f negative 1 of x. Correct? So let's see. F of negative 1 of x is the cube of the cubic root of x plus 1. So we have to put this one inside this one. Minus 1. And then the cubic root and the cube cancels. So we have x plus 1 minus 1. And the ones cancel, so I have x. Then I can do the composition f negative 1 of f of x. And this is going to be the cubic root of, let me see, is the cubic root of x cubed minus 1 plus 1. So I have to put this one here inside. Now we can cancel out the ones, and this is the cubic root of x cubed. This cancels. And then the cubic root cancels with the cube, and we have x. So this is the way we check that is the inverse. You did this before, so we are not going to do any practice about this one. The only situation is I want to show you how to get this graphically, right? So here I have, for instance, this is f of x squared. Everybody remember this parabola. Now, how's the graph of the inverse? Well, what we did here was, you see here, you change the x by y and the y by x. So it's exactly what I'm going to change here. I'm going to change the y by x and the x by y. So I'm going to flip this over. You see, I changed the y by x and the x by y, and the graph of the inverse is precisely this half right here. That is the graph of the square root. It's very simple. In the case of the cube is this one. This is this exactly, x cubed minus 1. So we change the y by x and the x by y. So I'm going to flip this over, you see. I change the y by x and the x by y, and then you can see the graph of the inverse. So it's very simple to get the graph of the inverse, correct? So, well, this is what we are going to do to find the inverse of the trigonometric functions, correct? Okay, let's go back to this part. This is the graph of the sine function. I guess everybody's familiar with this. Well, how can we get the graph of the inverse of this thing? Well, if we remember the previous examples, the only we have to do is change the y by x and the x by y. Okay, we flip this over, and when we find this, it says, oops, mister, this is not a function because if we do the straight line, the vertical line, this line crosses several times the graph. So this is not a function. You see, that's correct. This is not a function. So what we have to do is restrict the domain. So we are going to cut the sine just at a little fraction such that the horizontal line does not intersect this more than once. So you see the horizontal line is going to intersect this several times. So I'm going to eliminate branches that may have this problem. So I'm going to keep this one, right? So this portion of the sine is going to be inverted. So I'm going to have pretty much this section. This is the graph of the inverse sine, correct? For the cosine is going to happen the same thing. Suppose I have here the cosine. This is the graph of the cosine. Okay. Again, how's the graph of the function? The inverse function. Okay. I change the y by x, the x by y. So I flip this over. And again, the vertical line test tells me that this is not a function because it intersects several times. Okay. So I have to go back again to the cosine. And I have to restrict again the function. So I have to chop all those branches giving me trouble. So this branch is going to be chopped. These branches are going to be chopped. And then I'm going to get something like this. Now, any horizontal line has no problem, you see? Cross once. When we flip this one, y by x and x by y, we have exactly the same situation. This is the inverse of the, this is the graph of the inverse function. Okay, so the reasoning is not very complex. For tangent, we have the same. Okay, we change the y by x, the x by y, so we have something that is not a function. So we have to go back to the original. We chop the branches that give us trouble, so we just keep this part here. And if we flip this only, we are going to see that the inverse of the tangent is something like this. So everybody's catching the idea? So this is the graphic way to get the inverse of the trigonometric functions. Why I'm doing this? Because it's not possible to do with sine, cosine, tangent, and cotangent the same we did for x squared of x cubed. So there is no way to do that. So this is the situation. For the sine x, right? Y equals sine x. This is f of x. The reciprocal of the function, well, not the reciprocal, the inverse, is the sine -1 of x. Or also in the textbook, you are going to find that this is the arc sine of x. These two are the same the notation for the same function, the inverse of this. And the important part is this. Sine of arc sine is going to be x, and the arc sine of the sine is going to be x. So this is the definition of the inverses. So possibly it's very complex the first time, but it's not that difficult. It's just this definition, f -1 of x and f -1 f of x equals x. So this is what I'm doing. This is the definition of the inverse. So if this is the sine and this is the inverse, if I make the composition, I get a single x. So not big deal. Now, graphs for these ones. Okay, let me just share the screen right here, same document. These are the graphs of the sine, the cosine, the tangent, the cotangent, the secant, and the cosecant. The inverses are in this one. So this assignment is right here in the Google Classroom. Don't forget that. Okay, let me just activate this one. Let me just activate here. Oops, right here, right here. So if I share this with you, you see that, where is it? Right here. Okay, share. So if you see the Google Classroom, here is the assignment I'm showing you. This is the assignment having those graphs. Okay. Well, pretty much this is the main idea of the things we are going to do. So if we have cosine of x, right? This is fx. So the inverse is going to be the arc cosine of x. And again, if we do the composition, we get an x. And vice versa, arc cosine of x equals x. Well, you can tell me, Mister, this is very simple. There is no problem with this. But what we are going to solve is something like this. What if I try the sine of the arc tangent of x? So we're going to make composition of trigonometric function with inverses of other trigonometric functions, right? This is part of the things we have to cover in PreCalc. How can we know this thing? Okay, this is, well, this is what is in the assignment. Let me show you. So I'm going to share a screen right here. So these are the problems we're going to be solving here. You see, we're going to get the sine of the arc tangent of 3/4. Okay, so I'm going to write that. Sine of the arc tangent of 3/4. Okay, let me just stop sharing and go to our board. Here is my board, correct? Here is my board. Okay. No, there is now. Okay, how can we solve this one? Well, we have to recall this one. Everybody remember this? The definitions of the trigonometric ratios? Yes, Nati? You remember?
Yes.
Okay. The sine is defined as this one. If we have our right triangle right here, and we identify the angle, the opposite, the adjacent, and the hypotenuse, the trigonometric ratios are going to be solved like this one, correct? So sine is opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent, and the cosecant, secant, and cotangent are the reciprocals. So no problem. I want you remember this. You must memorize this one. Remember, find a way to remember this. If the famous SOHCAHTOA works, I'm fine with that. Okay, this is what we have to find. What is the value of this composition? Well, step number one, you are going to draw a right triangle. Okay, you are going to draw a right triangle, correct? Then, as in the triangle I show you, you are going to identify theta, correct? Then this is going to be the opposite, this is going to be the adjacent, this is the hypotenuse, no problem. Now, the second thing you are going to do is, okay, I know the ratio of sine theta, okay? Sine theta is opposite over hypotenuse. This is what I know. Sine theta is opposite hypotenuse. Okay, but the problem is here, who's theta? Okay, who's theta? What I'm going to do is I'm going to match this expression with this expression, correct? This expression with this expression. So in this case, theta is the arc tangent of 3/4. This is the theta. See, if I match these two, right? If I match these two, theta is the arctangent of 3 over 4. Okay, and what we're going to do with that, mister? It's very simple. This is the trick. If theta is the arctangent of 3 over 4, then tangent of theta is 3 over 4. So I'm going to use the inverse function. So what I did is very simple. I took tangent of theta equals tangent of the arctangent of 3 over 4. So I make the composition. And by definition, I know this cancel out. So tangent of theta is 3 over 4. So it's very simple. Okay? Now, what is the definition of the tangent? Okay, I have to go back to my old board. Tangent is opposite over adjacent. Okay, so it's opposite over adjacent. Okay, so I know these values now. The opposite is 3, the adjacent is 4. So the opposite is 3, the adjacent is 4. Correct? Now, how much is the hypotenuse? Well, remember the Pythagorean theorem. 4 squared plus 3 squared, correct? This square plus this square is this square. This is a right triangle. Now, 16 plus 9 is 25. And 25, the square root is 5. So my hypotenuse is 5. So to answer this problem, this one, the sine of this one, the only I have to know is that sine of the angle in this triangle is 3 over 5. You see? This is the definition of the sine, opposite over hypotenuse. From this triangle, this is the opposite, this is the hypotenuse. So the sine of the angle is 3 over 5. And because the theta is this one, then sine of the arc tangent of 3 over 4 is 3 over 5. And this is the answer of the problem. A little bit long, but not difficult because you have the definitions memorized, I hope. So you can find these values pretty simple. Okay. Questions at this point? Everybody's clear? Liana Jaimes, let me just admit this one.
¿Nos va a dar tarea o no?
Hmm?
¿Vamos a tener tarea?
Yes, you are going to have a homework about this one, okay? So, but I want to do several. It's very simple. Remember, where is the homework? Okay, the practice you are going to do independently is right here. Is right here in the Google Classroom. Here are the problems I'm solving with you. This is the practice, okay? The H4710. So you will have to download this one and copy the assignments. The way you are going to send me this, I don't know. This is a document, possibly we take pictures and check those pictures. Or you upload it in your Google Drive and then you share. Well, we're going to find a way. Okay?
Póngale 100 a todos ya.
Okay, let's take a break right here. How is going to be the grading? I have no idea.
Okay.
So I can give you grades, I can give you assignments in Math Excel, but the district has to define how we're going to be grading, okay? So the last valid grades are the ones you saw in your report card. So I guess we're going to improve those grades in some way, but how? I can work with you, Math Excel. We have been using that, but I don't know, correct? So very possible we are not going to know until the end of this week. The other thing, seniors, I don't know what is going to happen with your ceremony of graduation, okay? I don't know nothing. I know.
Oh, imagine being a senior. Sucker.
I don't know.
Gonna
So
be
the situation is very
sad.
simple. The GPA for seniors, the last GPA for graduation is calculated in May. So at the end of the fifth 6 weeks. The problem is we are in the fifth 6 weeks, right? So I don't know if the seniors are going to be calculated with grades now, or they are going to take the 4-6 weeks only, or the first semester only. I don't know. Second one, ceremony of graduation, well, is the first week in June. Possibly by that time everything is going to be okay. So, but prom is canceled, okay? So seniors, no prom. It's
Oh,
canceled.
ya fe.
So everything you spend in the dress and the things, forget it. Prom is canceled. Okay? Bueno, no questions here. I'm going to solve another one. Let me raise this one.
No, pues ya Rubén.
Ya valió quex.
Okay?
Ya estás teniendo para nada, güey.
The next problem I'm going to solve is this one. Let me just share the screen. Here is share. The next problem is this one. We are going to find the value of secant of the arc sine of 4/5. So how much is this composition? Okay, let's see. Stop here. This is the composition. So again, step number 1, remember, draw a right triangle. Yeah, this is part of the procedure. You draw your little right triangle, you identify your angle, and then from this right triangle, you're going to see that this is the opposite, adjacent, hypotenuse. Okay. Now, what you have to find? Well, the secant. The secant of the angle is, well, the secant, you remember your ratios, the secant is hypotenuse over adjacent, correct? This is always what I have to recall. Hypotenuse over adjacent. Okay. Hypotenuse, adjacent. Okay. Well, now remember that you are going to match these two. So, what happened this one? Okay. So, theta is the arc sine of 4/5, correct? 4/5. Well, remember, we're going to use the inverse. So if theta is the arc sine of 4/5, then sine of theta is 4/5. This is the point, correct? Sine theta is 4/5. Okie dokie. Now, remember the definition of the sine. The definition of the sine again, opposite hypotenuse. Okay, so this is the opposite. This is the hypotenuse. So I match this in my triangle. The opposite is 4. The hypotenuse is 5. Okay, now I'm going to use the Pythagorean theorem to find this one. So remember, a squared plus b squared equals c squared. If you need the hypotenuse, c squared is, if you need one leg, is b squared equals c squared minus a squared. Then you square root, and then you get what you need, correct? Well, I'm going to do the same here. This is 5 squared minus 4 squared. 5 squared minus 4 squared. And you know that this is 3. So my adjacent is 3. So I'm going to do that. Use of that value. Secant of the angle is hypotenuse. Well, hypotenuse is 5. The adjacent is 3. So secant of the angle is 5/3. So the problem I have to solve, secant of the arc sine of 4/5 is 5/3. Everybody fine with this one? Everybody alive? Okay. Any question here in this problem? Remember, what we're using, a right triangle, the definitions of the trigonometric ratios. So we are using something you already know. So you know this thing, right? Then when we receive something like secant of something like this, the arc sine, the inverse of a trigonometric function, we take this as the angle, like here. Then we use the inverse. We take sine both sides, this cancels and get 4/5. So I have the sine of the angle is 4/5. Then I return back to the definition of the trigonometric functions to know the length of this triangle I drew here. I identify the sides, I put the values on the triangle, then I use the Pythagorean theorem to solve the missing, and when I find the missing side, I use the definition of the function I'm looking for. What is the definition of the secant? In this case, hypotenuse adjacent. Then I read the hypotenuse and the adjacent values from my triangle. I plug in here in my expression, and then the final expression, returning back the theta as the original thing I got, I get the answer for the problem. So it's not very difficult. Let's do the last one for today, okay? I don't want to overwhelm you with so much. Tomorrow I'm going to repeat this again, okay? For the ones that miss the thing. Problems like this. So what is the next problem I'm going to solve? Okay, I'm going to share my screen again. Here is the screen, so I'm going to solve this one. Cosine of the arc tangent of 2, correct? This is what I have to find, okay? Let's go back to my board. Here is my board. Cosine of arc tangent of 2, okay? Again, step 1, I draw my right triangle. I sketch my right triangle. Theta. And, well, what I need to find? I need to find cosine of the angle. Well, the cosine is adjacent over hypotenuse. Okay, well, I match these two expressions again. So theta, yeah, theta is the arc tangent of 2. Okay, well, I'm going to use the inverse function. So tangent of the angle, let me just put this a little bit below. No, it's fine. Tangent of the angle is 2. Okay, but the tangent is defined opposite over adjacent, correct? Opposite over adjacent. I don't have a fraction, but you know that 2 is 2/1. So my opposite is going to match the top number, and my adjacent is going to match my bottom number. So the opposite is 2, the adjacent is 1. Okay, so I have to find the hypotenuse. Okay, according with the Pythagorean theorem you learned in the middle school, this square plus this square. 1 square plus 2 square. Okay, 1 plus 4 is 5. So this is a square root of 5. Okay. That's very simple. This is the hypotenuse. So the cosine of the angle for this triangle is the adjacent, that is 1, and the hypotenuse, that is the square root of 5. Okay, so the cosine of the arc tangent of 2 is 1 over a square root of 5. Okay, by now don't worry to put this radical out. Yes, I know that this is going to be a square root of 5 over 5. Yeah, if you want to do that, it's correct. If you do only this, it's correct also. So, not a big deal, correct? Everybody fine with this?
Yes.
Okay, well, questions? Zamora, Bethany? No, Aaron, Aliyah? Are you still there, Aliyah?
Yes, hi.
Okay, very good. Let me see. Gianna Jaime, mute. Mute,
Rafi, unmuted me.
Diamond. Okay. Remember, I'm going to put in the Google Classroom the link for this video you can watch in my YouTube channel. I'm going to save and then I'm going to upload it in the YouTube channel. Okay. Let me see now one last example. So I share this one. Okay. This difficult one. What happened when we have negatives? This is, oh my God. Okay. Secant of the arc tangent of -3/5. Correct? Okay, stop sharing. So this is what we have to solve now. Okay, I'm going to begin again with my right triangle, right? As normal. And I'm going to put here my angle. So usually I begin with a regular right triangle. But let me see now what I need. Secant of the angle is defined. Remember what is the secant definition? Hypotenuse adjacent. Now, I know that the theta is the arc tangent of -3/5. Okay. Now, according with this, the tangent of the angle, I use the inverse, is -3/5. Okay. Here is my first problem in this situation. I have a negative here, and the situation is this. The negative could be the 3, the negative could be the 4. So really, I have not this triangle, but a different one. So this could be -3/5 or +3/5. So those are the ones, correct?
Yeah, let's drink it over here, okay? On your place, man.
Okay, ready? So this is the problem I have now. This is okay, well, so this triangle is going to change a little bit. For the first case, I have, let me see, let me just put here the XY. So let me just put this one right here. So -3 is the opposite. Well, this is the opposite over adjacent. So the opposite is -3. Okay, the opposite is -3. So my triangle is going to be down. This is the opposite, -3. And this is +5, correct? So the angle is possibly this one, right? It's okay, well, what is the other one? Well, the other one is, well, let me just put the same axis here. The other one is -5, is the adjacent, so the adjacent is -5, and the opposite is 3. So it's going to be something like this. I'm going to have this angle, correct? So 3, -5. Okay, what is the only situation here? The hypotenuse is always positive. If you square this one, you have the square root of 9. The square root, no. You have the square root of 9 plus 25. And 9 plus 25 is 34. So this is a square root of 34. Okay, well, let me just now think about this one. Secant is hypotenuse over adjacent. Okay, so secant of the angle is the hypotenuse. Well, that's not a problem. This is the square root of 34, correct? Over, okay? The situation is the adjacent could be +5 or -5. So I'm going to have this one, or secant of the angle is going to be the square root of 34 over negative square root of 5. Here the situation is I may have to answer. So remember, the adjacent could be 5 or it could be -5. So because I don't know which one is what, I have to give two answers to this problem. So the secant of the angle is this, or the secant of the angle is this. In other problems we are going to solve, we are going to decide this one, correct? But not now. So, secant of the arctangent of -3/5 is positive, negative, the square root of 34/5. Why the positive? Because this positive. Why the negative? Because this negative. So we're going to keep this answer. Okay, so as you see, it's the same solution for all the problems. The only situation is if I have a negative and I have adjacent hypotenuse, the two legs, they can be negative. The hypotenuse never is negative. Remember this. Hypotenuse is always positive. Okay? Well, I guess this is good for today. So don't forget to go to the Google Classroom, right? And download these two assignments. Check the problems we are going to continue solving here and check the first page of this one. Try the first problems in the same way we solved the first page here, okay? That's the situation. And technically tomorrow at 8:30, we are here again, okay? If something happens, if there is a situation, I send you a remind, canceling the session, but I guess this session is going to be fine. Okay, no questions, no complaints, everything fine?
No, mañana yo tengo clase.
Bueno,
Hasta-
remember, whatever I put here is going to be recorded, okay? So you can check in the YouTube channel what happened in the class you missed. I'm going to do more problems about this one, so you're not going to miss too much, okay?
Okay.
Okay, well, chicos, have a good day, take care, be safe, right?
Ramírez.
Social distance, por favor. Nada de besos al novio. Bye.
Usted, Ramírez.